Hello and welcome to the AI Engineering Podcast, your guide to the fast-moving world of building scalable and maintainable AI systems. Unlock the full potential of your AI workloads with a seamless and composable data infrastructure. Bruin is an open-source framework that streamlines integration from the command line, allowing you to focus on what matters most, building intelligent systems. Write Python code for your business logic and let Bruin handle the heavy lifting of data movement, lineage tracking, data quality monitoring, and governance enforcement. With native support for ML and AI workloads, Bruin empowers data teams to deliver faster, more reliable, and scalable AI solutions. Harness Bruin's connectors for hundreds of platforms, including popular machine learning frameworks like TensorFlow and PyTorch. Build end-to-end AI workflows that integrate seamlessly with your existing tech stack. Join the ranks of forward-thinking organizations that are revolutionizing their data engineering with Bruin. Get started today at aiengineeringpodcast.com/Bruin, and for DBT Cloud customers, enjoy a $1,000 credit to migrate to Bruin Cloud. Your host is Tobias Macy, and today I'm interviewing Niklas Gustavsson about how Spotify is scaling AI usage in engineering and product work. So Niklas, can you start by introducing yourself?
Yes, thanks for having me. Yeah, so I'm Niklas. I'm Chief Architect Spotify. I've been here for, coming up on 15 years in the summer, so quite a while. And one of the areas that I've been focused on for the last few years is very much around our developer experience and how we leverage AI in our development workflows.
And do you remember how you first got started working in the ML and AI space?
Yeah, my background is actually not in ML. My primary background before Spotify was in backend and distributed systems and things like that. But of course, as I joined Spotify and we started heavily investing into machine learning, I guess more than a decade now, it's always been close to what we do. It's deeply integrated into all our product development and so on. So it's always been very close to me. But then, of course, as Transformers and LLMs came about a few years ago, that got much closer to everything we do. So that's where I really got deep into our AI strategy and has ever since been spending a lot of my time on that.
And digging into the main topic here, before we get too deep in the weeds, can you just start by giving a bit of an overview about the general engineering structure and some of the developer experience investments that you've made independent of any AI tooling, maybe in the years before GPT came onto the scenes?
Yeah, absolutely. So it might be good to know, as I think we'll probably come back to some of this as well. Spotify, we run a highly distributed architecture. So we have many thousands of production components that might be, backend services, mobile components, machine learning, pipelines and models and so on. And these are designed and owned and operated by a fairly large number of development teams, something like 800 development teams. So in a sense, it's this there's both a lot of intention about our architecture and the way that we work, but it's also highly distributed. So there's some level of, chaos to it, which is both fun and challenging. It is a very collaborative environment. We do a lot of back and forth between teams. Something like 40% of our pull requests are from a non-owning team. So if I own a backend service, a lot of the changes to that backend service is actually going to come from some other team. And this is always going on in between teams. So there's, lots and lots and lots of collaboration. And a few years ago, we shifted a little bit. So it used to be that we were a super autonomous company. Every team had a very high flexibility around what they built and how they built the things. And we just didn't see that this worked very well with the scale that we were at. So a few years ago, we started efforts around an increasing standardization of our code and practices, and also made an investment into better ways of managing our entire fleet of software. So it used to be that every team would own their own components, and when we, let's say, needed to upgrade some language version or library or whatever, we would tell each team that, hey, you need to move to the latest version of Python or Java or whatever it would be. That just didn't scale very well. So we made all of these investments into instead being able to manage our entire fleet of software as one thing that we could sort of mutate. And I'm mentioning this because this will come back in terms of where we're also focusing when it comes to AI at the moment. So that's roughly the backstory for us, like a few or number of thousands of production components, 800 teams, very high scale for what we do, at least compared to my previous experiences. Like we have millions and billions of users connected at any given point of time. We have lots and lots of traffic. So it's a lot of fun and always been very fast paced over here.
And one of the key aspects of developer experience is that you're trying to keep engineers in that flow state, keep them focused on the problem at hand and not get bogged down by all of the various roadblocks and things that are technically necessary but don't really contribute to the actual product goals. So things like making sure that your linter checks passed, make sure that your CI runs in a timely fashion, make sure that you have good test coverage. And I'm just wondering, as you were investing in that developer experience, what are some of the main pain points or struggles that you were dealing with prior to the introduction of AI? And then we can get into some of the things that you're trying to use AI to solve for.
Yeah, so I think one of the main challenges that we saw was just a fragmentation of tooling for our developers. So it used to be as a developer at Spotify, you have to jump in between many different tools that either we had, some open source tool we were using, or we had built internal tooling, but in a very fragmented. So that was how we came about investing into what we now call Backstage, that we've also made available outside of Spotify. And it's this like single pane of glass that developers interact with, and it's very present as a developer at Spotify. You do a lot of your tasks every day within Backstage, and that's been, I think, if I would point out like a single productivity unblock that we've done maybe prior to AI, that's going to be the one. Like that was the one that really simplified the life of a developer. Now I can go in Backstage, I can look at any of our thousands of software components, and I can see all the actions that I can take on them and all the data and information that is available around them. And that was, for us, very different from the fragmented state we were in before that. And I think this is true for many other companies as well, but it's been a particular focus for us.
And now digging into the introduction of AI in the engineering workflow, there are various shapes that can take. There is a never-ending set of tools with new ones being introduced every day. And I'm wondering, as you were starting to see some of the potential for using AI to accelerate software development, what was the overall process for determining how and where and why to apply some of those technologies? Was it more of a bottom up and organic growth situation? Was it more of a top down mandate, or maybe some hybrid structure? Just wondering kind of some of the ways that you thought through that overall process and investment.
It has been, I'm going to say, largely a bottoms up driver within Spotify. We started out with a very strong internal demand for Copilot back in the days, and we went through the journey of being able to clear that so we could use it. It was a bit of a early days, so there was a lot of legal questions and security questions and things like that we had to figure out. But we were pretty early on jumping on Copilot, and then the journey has just continued from there. Like we had an incredibly fast adoption of Copilot within the company, and then Cursor came along, and then Claude Code came along, and we've continued to seeing these like extremely rapid adoption, like nothing I've seen for any other tool that we've introduced. So there's been an incredible bottoms up demand. We are, of course, trying to balance that with our being somewhat intentional and strategic about this. But I'm going to say we have gone very heavy on experimentation and sharing learnings and being pretty humble about that. We don't know exactly what's going to happen tomorrow, to your point of new tools being released all the time. So we've been pretty open and allowing for a pretty broad set of tools, and then encouraging our engineers to experiment and share as much as they can. And we have some very active internal Slack channels and repositories with Claude skills and things like that, where people are experimenting every day. So it is amazing to see at the moment, and I imagine that this will continue. The pace has only been increasing. So.
And to that point of the rapid pace of change, the rapid introduction of new tools, the evolution of existing tools, particularly from the perspective of developer experience and investing in the aggregate velocity of the organization, that variance can allow some people to move faster, but maybe at the expense of the broader organizational velocity. Whereas standardization, such as what you were mentioning with the Backstage investment of this is the way that you get to the thing, can make sure that everybody is moving in the same direction and at roughly the same multiplier of pace. And I'm wondering how you're thinking about some of that tension of wanting to standardize the tool chain, build around some of those capabilities, and share those best practices, while at the same time enabling people to do that pioneering exploration of figuring out what are the capabilities, what are the boundaries, and how do we determine what best practices to bring to the rest of the organization.
Yeah, it's a great question. I think that's putting the point very clearly on some of the trade-offs that we're having to make. So much like you described, like we are betting on standardizing a lot of our underlying foundational pieces. So that will be the infrastructure that we have in place, like the tools that we make available to our coding agents and so on, and on the code level. So as I mentioned before, we've been on a multi-year journey to drive that standardization, and we're continuing that now and accelerating that. And we're doing that through various means. Like one of the investments that we currently have ongoing is to move all our code into monorepos, which allows us to have a much higher degree of standardization than we had before, like where our code lived in thousands of small repositories owned by each and every team. So we were kind of lucky to make these like standardization, the fleet management, and the monorepo investments as AI happened to us. But so we're in that sense, like feel that we're relatively well set up, but it is also moving incredibly fast. So we're trying to adjust as we go along.
And to your point of some of the tools that are available to the agents, some of the coding standards that can be enforced using things like linters, CI/CD, et cetera, that is definitely one of those core engineering disciplines. And I'm wondering, what are some of the other foundational kind of first principles that are effective regardless of the specific harness that you're using for a given LLM, and some of the ways that you are investing in that kind of platform layer of enabling the agents to be able to get the context, understand the tasks, and maybe just some of the ways that the introduction of those agentic coding capabilities even shifts the focus of the people who are guiding and responsible for that work.
Yeah, it comes in many shapes and forms. So one that you mentioned in there was we need to guide those agents. So we're spending quite a bit of time at the moment to make sure that we have the right skills and rules set up for the agents so they are able to follow those, and that we have the right, where we need it, the right sandboxing as well. So we're doing it in a secure way. We're also investing into improving the verification loop. So one thing that we've seen is that the better testing we have in place, the better both agents, and in particular these like fleet-wide agents that we haven't really talked about, but I'll come back to, work. So let me dive down that rabbit hole a little bit. So I mentioned before that we made this investment a few years ago on what we call fleet management, which is all about like managing our entire fleet of software as one thing that we can make changes to. The challenge with that was that the type of changes that we could make were fairly simplistic, because as it turns out, code is very complex to change. Like it has a very wide API surface in a way. And so we could make code changes, but they were fairly simplistic and shallow in a way. So one thing that has fundamentally changed now is that we can use AI agents to make those changes for us and then orchestrate and roll those out across our fleet. And that means that we can significantly raise the bar for how complex changes we can make to our fleet. But that means that we really need to have a good test automation, a way to verify that those changes are correct and safe. Again, luckily, we did some of those improvements as we started rolling out fleet management stuff a bunch of years ago, but we think that we need to improve that further now. So that is one of the investments we're doing. We're both revisiting our practices around how we do tests and also our test coverage in the fleet. Luckily, agents are actually an excellent tool to also write some of those tests for us. So we think we can get some benefits from that. So those are some examples of these like more foundational capabilities that we're building out, but there's lots more of those. Like we built out an MCP infrastructure internally as well, for example, to make sure that we can provide many different MCP tools and do that in a secure way.
Your comment on fleet management also brings up an interesting nuance to the overall engineering challenge, is that there are different styles of engineering within an organization, where you have your application engineers who are focused on writing the features, making sure that the end user experience is fulfilling the overall organizational product goals. And then you also have data engineers, ML engineers, operations engineers, platform engineers, and all of those roles are going to have some set of code that they are interacting with, that they're responsible for, that they're going to be managing. But all of that also has to be deployed and maintained and monitored in the production environments, which is its own set of engineering challenges, that has its own set of agentic capabilities that are being developed across the ecosystem. And I'm wondering how you're seeing the adoption and application of these agentic capabilities differ across those different styles of engineering or domains of responsibility.
So I agree with the sort of classification of different disciplines that you outline, but I think they've started to meld together a little bit, both as we've been, again, like doing these investments in thinking about our entire fleet. So it used to be that as a developer, you were at Spotify, you were very close to the code that you owned or your team owned. But now we're more in a mode of like, yeah, you still own some piece of or some number of components within your team, but many other teams in particular are more platform teams will also make changes to that code. So code has gone from being this thing that like I own to Spotify owns, and in a sense, like everyone can make changes to them. There are still access rules and ownership around them, but the principle has changed quite a bit here. So I feel that some of those, like the distinction between what we would call a feature engineer, like the app engineer, and a platform engineer used to be very distinct, but it's much less so today. That being said, I still think that the way that we apply AI tooling into this, there's lots of similarities, but also a few differences. So again, the typical feature engineer, like working on one of our mobile apps or let's say on our playlist systems, they will be fairly focused on those systems and like building new features and rolling those out to our users, and then operating those components. And that tends to be that then you're focused on a smallish set of code and your very like deep expertise on that particular domain. And that means that you will use AI agents typically, like I would say, in the sort of mode that they were primarily developed towards, like what most engineers would do. And then if you look at our platform engineers, they are very focused around, again, like managing our entire fleet of software. So they will then use more scheduled jobs and things like that. So one of the things that we built out as part of our AI agents is something we call Honk. It's kind of silly name, but it's really a way for us to, and again, using this fleet management infrastructure that I mentioned before, really a way to take like a AI agent in currently Claude Code under the hood to apply that to our entire like millions and millions of lines of software. And that's been incredibly powerful in terms of being able to drive changes to our software and, do code modernization and things like that. So, and that's really something that, like, I'm going to say mostly our platform engineer, mostly but not exclusively our platform engineers are focused on. So under the hood, they're using the same tools and many of the same practices. It's the same way of prompting. It's the same way of working with agentic tools and whatnot, but the focus for their efforts tend to be a little bit different. So that's the main distinction that we have. We don't have, you mentioned like operations engineers. We don't have separate operations engineers. Like it's the same teams that build and own our software that also operates it. So we don't have some of those categories that you mentioned. But I would say that's the big distinction that we have.
And then in terms of the shape of the engineering work, I'm wondering how you're seeing the distribution of work change as far as what stage of the software lifecycle more of the time goes into now, where for most of the history of writing software, you had maybe a product manager or an architect who would be responsible for saying, this is how everything is going to fit together. These are the features that the end users are going to be delivered. And then I'm going to write all of the tickets, and then I'm going to hand that off to an engineer who's going to write all the code and test it and make sure that it gets deployed effectively and monitored. And with agentic coding in the mix, it changes that equation a bit, where the writing of the code part can sometimes move from taking weeks down to minutes, depending on exactly what you're doing. But making sure that it's generating the right code is really the challenge now. And I'm just wondering how you're seeing that change in dynamics shift the time investments, where maybe rather than it being that middle point that takes up most of the work of actually writing the different lines of code, you spend more time instead making sure that you understand the problem and the specification. And then it also puts a higher burden on the review and deployment stage, because you need to make sure that the code that was generated is actually accurate and correct and doing what it was designed to do, and just how that's changing the dynamics of the engineering org at Spotify.
Yeah, it's a great question, and many of the things you mentioned there really rings through. So let me talk through some of them. So first of all, I think our product development process has always been a little bit more collaborative than what you described. So it hasn't been those like clear handovers of like the product manager writes down a spec and hands it over to a developer. That's always been very iterative within Spotify, but we do have those roles. We have like product managers that will think deeply about our product strategy, and then engineers, to your point, who will then design and build and operate the software to manage that. And yeah, and like you said, like that part of turning those ideas into code, that is obviously dramatically changing now. Like it is, just like you said, going from potentially weeks to hours, and the work for us and me as a developer has changed dramatically as well. Like I used to be someone that loved the, hands on keyboard, solving problems through code type of challenge. And I literally haven't written a line of code now in like 2 months, because all of that is being done for me with the agents that I use. And that is a very, very different way of thinking about it. And me personally, I really enjoyed that transition. Actually, it turned out that it wasn't that hand-on keyboard thing that I enjoyed. I enjoyed being able to solve problems and shipping those to users more than the hands-on keyboard. This is obviously going to be personal and different for different people. But for me, it's been a pretty fun experience in so many ways. And it is shifting some of the dynamics that you mentioned. Like it is shifting the work for us as developers more towards how do we effectively translate these ideas of things we want to do into input for the agents that we use. And then to your point, then reviewing the output from those agents. And we are leaning heavily on applying human judgment in both of those cases, like making sure that we provide the right set of inputs for the agents so they do a good job, together with all the stuff that we've talked about before, with making sure that we have the right foundations in place. Like the agents, just like humans, knows what code standards we expect and what levels of conventions and security and so on that we expect. And then we put a lot of accountability on the developer to then review the output of the agent, both in terms of me sitting in front of the agent, but also as part of our peer code review. So that remains super important to us. But it is also challenging, right? Because now we're able to produce much more code changes, and a lot of that happens purely like in this agent loop, and much more quickly than before. But we still need humans to review all of those code changes. So it's putting a lot of pressure on the code review stage before things goes into production. And that is something that we're working on figuring out right now. So putting more, we already have, but we need to improve the AI assistance that we provide for code reviewing. And we're going to change a little bit the policies that we have around how we do code reviews. So more people can contribute to those reviews than is the case today, for example. And then the last reflection I'll add in is that you mentioned again, like going back to those different roles that we have with like product managers, designers, engineers. Similar to what I said before, in between the different disciplines within engineering, we're also seeing that those boundaries between what it means to be a product manager and an engineer are loosening up as well. Like we see a lot of PM spending time in Cursor and Claude Code and, building prototypes, contributing to our code in a completely different way than was the case before. So I don't necessarily expect that these different disciplines will completely disappear because there are different expertise there. But these like handover boundaries that you started with, like those I think are going to look very, very different in the future. And I fully expect that where we have congestion points today within that process, like you mentioned, like the code part having taken a lot of time historically and that now moving away, that's just going to create new congestion points. So one of the things that we're preparing for is being able to detect those quickly and then being able to make decisions so we can iterate our way out of that. I think this is going to be a big part for us in the next few years, just to transition through this. And we don't have a perfect, view of the future of what this is going to look like. But yeah, I mean, everyone are using these tools today. We have a ton of adoption outside of the engineering cohort for both Cursor and Claude Code, and like everyone's trying to use them for many different things that you would be surprised about, that like wasn't necessarily what the tools were intended to from the beginning, but people are having a lot of good luck in like using them for other things as well. And the world of, just like the world of an engineer has been completely revamped in the last few months, I expect that to happen with all disciplines within Spotify in the next year or two.
There are a couple of different things I want to touch on here, and I'll just note them now before we get too far down the path. But I think that one of the things I really want to dig into is some of those other ways that you're seeing some of these agentic utilities being applied. But before we explore that, in terms of the validation and review stage, I'm wondering how this speed of code generation and the need for context cues and rapid feedback for the agents is changing some of the ways that you think about what languages to use, how to invest in things like type annotations, and just some of the overall tooling that you're investing in for linting, testing, validation, canary deploys, et cetera. Just some of the ways that it's shifting your thinking about which languages and which tool chains are best now that you don't necessarily have to spend all of those extra keystrokes on putting in those type annotations, and just because you don't have the benefit of engineers being lazy, but also the potential downsides that can have as far as not wanting to put in the extra work of, I don't need that type annotation right now. I know what I'm trying to do, but maybe the LLM doesn't. Just some of those trade-offs.
Yeah, I'm going to say that as a company with lots and lots and lots of code, as I mentioned before, and many, many different teams. And we have I didn't touch on this before, but we also have it's very often that like ownership of components will move around within the company. Like I built something, but it's now closer to the business problem that you're trying to solve. So I will hand over those backend services or whatever it might be to you. So given this, and this has been the case for many, many years at Spotify, and given this, we have always been pretty strict around like what languages do we use, what conventions do we have in place. And so a lot of these things we had to solve many years ago prior to AI taking over. And I think it has turned out that a lot of those things that were good things at scale when you have thousands of engineers also turns out to be good for AI agents. At least that's with the current generation of those agents. So I'm not seeing us making it, ask me again in 6 months and maybe my view has changed, but at the moment, I'm not seeing us making a ton of changes in those like very foundational decisions on what languages we use or whatnot. What we are doing is that one of the big shifts that we're going through at the moment is a lot of the standards that we've used, like the way that we've used to promote the standards within Spotify has largely been guidance towards engineers. So we've had Tech Radar and various documents that tells you how to build a ML pipeline within Spotify. And that's been reasonably effective, but we don't think it works very well for agents. So one of the things we're doing now is really to put more of those like closer into our code bases. So rather than being guidelines, they're going to be lints instead. So that is one of the changes that we're doing at the moment. And we're shifting a lot of those things into our actual code base. And this also goes hand in hand with the investments that I mentioned before of like moving to more of a monorepo structure, because one of the things that's been really hard for us historically has been, I mentioned having thousands and thousands of production components. They lived in thousands and thousands of Git repos, and trying to manage that and like reasonably enforce our standards in all of those tiny repositories with hundreds of teams owning them has been very hard. So there's many challenges for us to move to monorepos, but one of the benefits we're getting is like we have this one place where we can put all of these standards in place and all of the linting rules in place. We've done this for our clients for many, many years. They've always been in monorepos, but not the rest of our software. So we're sort of catching up with that now. So that gives us much better tooling for doing some of these things as well.
And also, one of the things that you mentioned is identifying what are the points where you are hitting bottlenecks in the path to delivery. And that's definitely an area where the overall industry has been investing time recently, is in figuring out how do you identify those bottlenecks using things like DORA metrics, I think is the most widely adopted one. But just wondering, what are some of the ways that you are quantifying some of those aspects of the engineering lifecycle, and in order to be able to identify those bottlenecks and hotspots?
Yeah, so we have I'm going to say very good instrumentation of our developer workflows. So we capture data from our production systems and whatnot, and that goes into BigQuery in our case, and you can go in there and make queries around pretty much everything that goes into our developer workflow. So in that space, we're in a pretty good state and we have lots and lots of metrics that we track, like DORA metrics, but also much more fine-grained metrics that we catch and track all the time. So we're in a pretty good state there. Unfortunately, that is not true for the broader product development process that we have. So we do have pretty significant gaps around being able to measure and quantify, let's say, how our PMs are working or how our designers are working. So as we're seeing these congestion points shifting around, I'm reasonably confident that we'll be able to see them within what our engineers do. So I mentioned before the code review. We're starting to see some of that popping up in code review, and we could clearly see that in our metrics. It's not as obvious how we're going to see that in a quantifiable way when it comes to the broader product development process. I think we're going to have to rely much more on user research and surveying and those types of things to capture some of those. I honestly think that's going to be a bit of a challenge for us over the next few years to really detect those early enough before, as they become a real problem for people, then it's obviously going to bubble up and we'll be very aware of them. But I would not love to be able to identify them earlier than that. But that I think is going to be challenging for us in some cases.
And so digging now into some of the broader, side effects of introducing agentic capabilities into the engineering lifecycle, I'm curious some of the ways that you're seeing those capabilities applied beyond just the stage of I can generate a boatload of code as fast as I want, and just some of the ways that it's leaking into other aspects of engineering work, product work, and just some of the maybe new code that it enables because of the fact that it is so fast and easy, and also maybe some of the ways that it changes some of your patterns around documentation and diagramming.
Yeah, so let me actually go a little bit broader than that to start out. So one of the very eager set of user group that we've seen has been our product managers that we've been talking about a little bit before here. And they are many of them are really picking up these tools. And again, they are using the same tools that our engineers are doing. So they're trying to figure out their ways around how to bend the cursor in Claude Code. And it's, many different ways of improving how we write PRDs or how we evaluate experiments and doing insights analysis and many, many different things. And we've had a number of internal tools and websites pop up for that target audience of, again, managing the life of being a product manager at Spotify in a better way. So that is one way that I've been particularly impressed with some of the innovation that's come out of that group. And I think we haven't talked about vibe coding yet, but I think that's been one of the things that they've really leaned into. And compared to before, where they would need to go to, they might have had some of these ideas around these tools before, but they weren't really able to build them because they would have to go to an engineer and convince them to spend time on building out some web tool for that idea they had. And now that's, a few prompts away. So we have a lot of these experimental tools popping up and people having ideas around how to, again, like improve the non-engineering parts of how we build products. Within engineering, what we've seen is like we see this sort of coding part of this, which we've been talking about. One of the interesting parts with coding is that it's actually a fairly small part of what engineers spend their time on. So it's roughly out of your 8 hours a day, it is roughly 1 hour that engineers spend like hands on keyboard writing code. This seems to be fairly consistent across companies, so it's not unique for us, but like there's been a bunch of companies sharing that research, and it's true for us as well. Like we're able to measure that. And then there's a broader set of development tasks. So this will be, debugging, operational duties, code review, those types of things. That builds up to roughly 3 or 4 hours of the day, and then the rest is spent on planning, coordinating with other teams, reading, writing, documentation, those types of things. So it is easy to I think overly focus on this 1 hour a day and trying to make that as quickly as possible, which like the tools that we've been talking about today has been amazing at. But we're really, even if we're 10xing that share of the work that engineers do to the previous points of just like finding new congestion points, we won't actually make Spotify a ton faster by just optimizing that. So we've been focusing on what are other use cases outside of that 1 hour where we can apply AI early on. And it used to be that if we would have talked a few months ago, you would have heard me talk about the various strategies that we had for that, of how are we bringing AI into being on call or managing incidents or whatever it might be. And that is still very much something that we think about and have strategies for, but also where we've been out innovated by our employees. So there are now all of those tools available internally. People have there are multiple tools that's been built for how to, for example, help people managing incidents. And we've taken one of those and made them the sort of canonical tool that we now provide to the company, but other people are still experimenting with other ways of doing that, which is amazing. So I think we're seeing this spread out. So what I imagined, again, if we would have talked a few months ago, what I would imagine was we had this the coding task that 1 hour a day, and then we would gradually spread the use of agents out from that, because that was really what they were optimized for. I think what we're seeing in practice is that they're now being used for everything people do during their full workdays. Everyone will use them for, I use Claude Code to write documents today, or prepare for hiring interviews or whatever it might be. It is something where these tools have become ever present in every task that we do as not just engineers, but more broadly as well.
Yeah, and speaking as a technical manager, I was very pleased the first time that I realized that I could use things like Copilot or Claude or whatever to take the fuzzy sketch of these are the things that I need to do and then stick them into the issue template so I could actually write comprehensive and useful issues for being able to assign to team members.
Yeah, it is amazing. And I think, again, the amount of experimentation and innovation that we're seeing from people just being able to take these tools, which again, were built for a kind of different purpose, but being able to reuse them for every problem they're faced with has been amazing to see, and continues being amazing to see.
And one of the aspects of these agents being a double-edged sword is that while they are immensely powerful and can allow people to move much faster, they can also amplify problems where if you have somebody who doesn't properly understand the problem domain or doesn't properly understand the code base, they can guide the agent in a direction that is counterproductive. And then the other aspect of challenge in terms of the deployment of agentic capabilities is the cost factor of how do you make sure that you don't accidentally end up spending the entire company's budget on a question and answer session that ultimately does not provide any actual return on investment.
Yeah, so the first part, I think, honestly, I think the first part of that is the most important, and that is really to create a culture and practices where you have that human judgment in the loop, so you don't blindly trust whatever is coming out of the agent. One good and recent example on that we've done is we have an internal tool for essentially being able to prompt our data. So I mentioned before that we have, for example, data on the developer process, and there's a bunch of data sets for that. That can be pretty daunting if you're not super familiar with SQL or our internal data sets and whatnot. So one of the ways that we're trying to bring that capability to more folks within Spotify is to allow you to prompt for that instead. Prompt the type of problem you want to solve, and that tool will generate the SQL for you to try to answer that question. That is great, but it's also pretty prone to introducing errors into those SQL queries that will be very hard for a less experienced user to detect. So that's a tool where we have spent a ton of work to make sure that we have the right validation in place of those queries before we show them to the user. This could otherwise lead to, us taking decisions on incorrect data and things like that. So we really want to be careful about that. So that's one of the cases where we've spent a lot of effort to make sure that we do the validation before we, again, show it back to the user. And we're trying to do the same in all of these tools. And like I said, we're trying to make sure that we have places within the processes where we still have that human in the loop remaining. I'm sure that will change long term, and there will be more of these cases where quality of the output of the agents are of high quality enough that we can remove some of those. But at the moment, we're still very aware of that and trying to be very careful about it. On the cost side of things, we've certainly seen cases where things goes a little bit haywire, but generally speaking, in most cases, the ROI of using these tools have been very strong for us. So we're not trying to constrain people too much by putting cost guardrails in their face. We do have those guardrails in place behind the scene to make sure that, what you said, in terms of some single use case going completely haywire, but we've seen very few cases of that in practice.
Another interesting aspect of Spotify as an organization and the incorporation of these AI and ML capabilities in the engineering lifecycle is that as an organization, you've been investing very heavily in various ML features and capabilities in terms of your core product. And I'm wondering how some of the expertise and lessons learned in the process of developing that operational capacity has fed into some of your overall adoption process for these AI utilities broadly in the organization, in engineering and otherwise, and also some of the ways that the lessons learned through that experimentation within the engineering team and across the different organizational areas has fed back into some of either the operational excellence of the ML features that you provide, as well as some of the maybe more generative capabilities that are being introduced in the product.
Yeah, it's gone both ways, just like you say. So, like I said early on, we have more than a decade of experience of building machine learning products at scale, and there's been quite a few of those things that we've been able to bring over to the productivity side of things. So, one such case is, for example, how we do evals of LLM-based products. So, to take a very concrete example, we have this internal chat agent called Aika, and it's all about providing our internal Spotify knowledge to our employees, and very much based on how we had experience working with our traditional machine learning consumer facing products. We reused a lot of that eval practices and infrastructure for how to build that chat agent. And the same is true for many other things, like how we run experiments and A/B testing for internal tools. We're reusing the same tools that we use for our consumer facing products, for example. I think it also, to be honest, allowed us to not do some things. So one decision that we were faced with, 2 years ago maybe, was, do we need to train our own model on our code, or will the rest of the world sort of catch up and be able to do that well enough without us having to make that investment? And I think that was one of the cases where we had a fair amount of experience from training both our own traditional machine learning models and transformer-based models, where we could better predict the future, and we actually avoided making that investment. And I know some of our friends in the industry went down that journey of trying to do that and then had to back out of it because the tools that we've been talking about today just became better than what they had internally. And then thinking about it in the other direction. So you mentioned this, but one of the I think interesting examples there has been we've now started talking externally about how we're moving towards a future with more control for the user over the recommendations that you get. And that has been very much informed by like how we're able to prompt these types of tools that we're using every day now. And then imagining like, what would that look like in the Spotify consumer experience? And you can imagine that many of those things that you're able to do with, let's say, Claude Code today would be as applicable to be able to do within the Spotify experience. So we already, like I said, we already started shipping some of those products, and you'll see us talk more about this in the future.
Yeah, I know that as a user of Spotify, I was pretty happy when I saw the natural language prompt to generate a playlist and being able to experiment with that. And I think your point of being able to inform the type of recommendations that you want versus it just being a black box that I, as a user, get whatever comes out of it is an interesting way of exposing more of these AI capabilities beyond the typical, the trope that was first introduced when ChatGPT came on the scenes of, hey, here's a chat box where you can talk to whatever, but it's not actually useful as an end user. It's just a gimmick.
Yeah, we think there's lots and lots of opportunity in that space. So we're very excited about what that will look like for Spotify as well.
And as you have been introducing these capabilities, investing in them, building some core tooling around that overall life cycle, what are some of the most interesting or innovative or unexpected ways that you've seen your team bringing these agentic and AI capabilities to bear?
Yeah, there's been many ways. We talked about a few before, like how people are using these tools now to build strategies. Like one of the things that if you would have asked me a year ago, that I would imagine being like one of the things where it would be hardest to apply these types of tools, but turns out that they're incredibly good at like, spitballing and working with you and brainstorming back and forth. And then in the end, you have a product strategy that is as strong or stronger than we could produce before, for example. We talked about incident management and how we're able to apply it there. And in our designers has been incredibly, what's the word I'm looking for? Creative in terms of like how they're able to use. We have a bunch of designers that spent time to like figure out how to use Cursor and ended up building these tools for other designers for like how to prototype things or how to. One very concrete example, if you go into the Spotify app and you go into our DJ feature, which is another one of these like more agentic features. That is like this visualization, and it's actually like driven by a bunch of parameters on how that behaves. And we actually had a designer, again, like vibe coding something with Cursor, where you can go in and like play with those parameters and make new visualizations based on that. So we've seen a ton of those examples, including like people using these tools for making their taxes or whatever problems they're faced with. So people are innovative around how to use these tools.
And in your own journey of understanding the use cases and capabilities and best practices around how to integrate these agentic workflows into your engineering organization, what are some of the most interesting or unexpected or challenging lessons that you learned in the process?
Yeah, there's been a lot around what we've been covering before in terms of having better verification, both in our code bases in terms of testing and so on, but also in that agentic loop. So we mentioned before this tool that we call Honk, which is this agent that we use to manage changes to our entire code base. And one of the real breakthroughs we had in developing Honk was really when we added in LLM-as-a-judge loop into that. So you can imagine like if you would be using Claude Code to make some changes, but before those changes are shown to you as a user, there's another sort of independent LLM that takes a look at those and takes a look at the prompt you were using and saying like, is this a good change or not? So you have that review loop always being built in. And that dramatically improved the performance of that tool. When you're using Claude like interactively, that's not a big problem, because if Claude does something wonky, you will just tell it like, change this thing. Like I do that 100 times every day. But when you're authoring changes that is going to be sent out as pull requests to like 1,000 different repositories, you don't want people to then have to iterate on those in 90% of those repositories. You want to catch those much earlier. So having 80 or 90% good output is just not enough in that scenario. You really need to get to that like 99% plus. And that was one of those cases where we were able to do that and really like make that jump in quality. That was transformational for that particular tool for us.
And I think, too, one of the key things in the adoption of these agentic capabilities that we've touched on throughout is the challenge of a lot of these tools being very much designed around a single user interacting with it directly. So it's more of the single player mode, but it has broader ramifications at the team and organization level. And I'm just wondering, what are some of the key ways that you have found effective in terms of being able to break out of that siloed mode of interacting with these utilities and turn it into more of a collaborative experience, and making sure that some of those useful patterns get captured without necessarily the engineer having to click the button to say, yes, this is the right thing, or just maybe figuring out what are some of those implicit signals around, oh, this is a useful prompting style, this one led us down a dead end, things like that.
Yeah, I'm going to say I think we're still very early in that journey, both as an industry and at Spotify. Today, like the patterns that we're able to use for that are, I find like still pretty manual in many ways of making sure that we update the skills or like Claude MD calls files or whatever that I would love to be in a place in the future where, just like you said, like these tools are much more collaborative. So if you and I are working in one of these agents, like the things that you do, and like the agent can learn from that and then reuse that when I work on the same code base, for example, so that we build up that collective memory in the agent without that having to be in this very explicit way that we do today. I very much imagine that this is something that we'll see coming in the tools in the near term future, and I'm very excited about that because I think that's going to make often we talk about these agents as being like another human in the team, and that's not what they feel like today to me. Like they're incredibly powerful, don't get me wrong, but they don't get that collective learning unless we encode that into skills or whatever. So I that seems to me like one of the things that will be coming. And I know that there's projects out there where people are experimenting with exactly those things today, and I imagine a lot of that will be coming in the near term future, and I think will be pretty powerful.
And when you're working with your engineering team and you are tackling a given problem, what are the situations where you decide that a human is the better operator and you eschew agentic utilities entirely?
I don't know if there's going to be a lot of cases where we completely not use agents. There's definitely going to continue being cases where the human will be in the loop, and pretty closely so. Again, like I mentioned, code reviews before, which we think are those one of those important things. Other things would be like working with our production data and things like that. But that is not something that like much of that has been automated since many years ago prior to AI. So it's not a very frequent task that we do. So I don't think there's going to be a ton of cases where we don't use agents at all. I think there's going to be cases where we still want the human to be in the loop. And then there's going to be cases that I think increasingly over time we feel more and more comfortable, more or less fully outsourcing to agents.
And as you continue to build the Spotify product, work with your engineers, grow your capabilities around these agentic utilities, and make investments in leveling up the broad capacity for bringing AI to bear on your engineering challenges, what are some of the things you have planned for the near to medium term, or any particular projects that you're excited to explore?
So I really want, as we were talking about before, I want to broaden the set of use cases where we get that like deep agentic impact that we have for coding today. I would love for that to be deeply integrated into how we manage incidents, because in particular, I think that's going to lower the time to recovery for those incidents, which is going to be important from a user experience point of view. I think it's, like I said before, it's going to integrate a lot of the work that we do within our product development process. So like bring together more of our disciplines working more closely together. So as a PM, I can visualize more clearly through prototyping what I want us to build. And then as a developer I can pick up from there. Like those types of things I'm pretty excited about, and really to zoom out and look at that full product development workflow rather than like only be looking at the coding tasks where we've been primarily focused historically here. So I'm super excited about that world. Then, of course, there are a million things we need to get right on the foundational layer that we talked about before, and a lot of that we're working on at the moment.
Are there any other aspects of your work that you're doing in the investment for your engineering teams and sharing best practices and investing in platform capabilities for agentic coding that we didn't discuss yet that you'd like to cover before we close out the show?
I don't think so. This was a broad and fun discussion. We went into many different areas. There are surely other things that we're doing, but I think we covered most of the ground on the interesting stuff we've been focused on.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gaps in the tooling or technology or human training that's available for AI systems today.
That's a big question, but continuing within the scope that we've been talking about here today, like I would love to see these tools getting broader into more of that full like development lifecycle and product lifecycle. Even though we're able to use them for many of those purposes today, I think there are still a fair amount of gaps that would make them much more impactful within companies like Spotify going forward. So, and I 100% believe that that's going to be happening. I would just love to have that today rather than tomorrow.
All right. Well, thank you very much for taking the time today to join me and sharing the work that you're doing at Spotify to make sure that everybody is able to take advantage of these new and exciting capabilities and all of the investment that you're putting into that and some of the lessons learned. It's definitely a very interesting problem space that all of us are trying to come to grips with. So I appreciate the time and effort you're putting into that, and I hope you enjoy the rest of your day.
Thanks for having me. This was great fun.
Thank you for listening. Don't forget to check out our other shows. The Data Engineering Podcast covers the latest on modern data management, and Podcast.init covers the Python language, its community, and the innovative ways it is being used. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at aiengineeringpodcast.com with your story.